I just wanted to save the battery. I thought I could close the screen over. Anyway, so let's start with the simple example we did for the for loop. Let's start with like a series of lines across the screen and see if we can rewrite it using a loop, right? So let's go void setup first of all. And then void draw. Alright, I'm going to draw a series of lines across the screen. We'll do it in 3 different ways. We'll do it first of all just using lines, right? So I want to draw maybe 5 lines across the screen and I want them spaced out at intervals of maybe 20. We'll start at 100 pixels across and then we'll 120 and we'll draw a few lines, right? So this is the way number 1. So I can go line 100 and then say down, let's put in some code here first of all. Size 500. Okay, so you go line, say, and let's say down 10, and then let's go over 100 and down 100. Alright, so is that going to draw a vertical or horizontal line?
Vertical.
Yeah. Horizontal.
Wait, no.
It is vertical.
Vertical.
Vertical line, okay, so that will draw a vertical line. Everybody knows why? What coordinates are we looking for the same if it's a vertical line?
The y, yeah.
The x coordinates will be the same if it's a vertical line, because we're going over a certain number of pixels, right? So we got one vertical line drawn there. Let's draw a few of them. Okay, so I've got 5 lines now, and now I'm going to change the x coordinate that I'm going to draw these lines. So this will be 40, 60, and 80. So then we can go 20, 40, 60, and 80, and we'll just make sure that this program runs before we try and rewrite this code. So I hit the play button, and hopefully I should have 5 vertical lines drawn across the screen, okay? So, we can rewrite this using a for loop, can't we? Just for some revision. So what will my for loop look like? For what? Let's go x. What's the first thing that goes inside the for loop there?
X.
Yeah, first thing first, what for what x? For what x? What am I missing? Yeah, sure, for x.
Interflow.
Okay, interflow. That's the first thing that goes there, interflow. So we declare our variable inside the loop like this, okay? You don't have to declare your variable outside the loop. As part of the loop, you can declare a variable. That variable will get created and destroyed, you know, as part of the loop. So you can go for int x equals, what should I start it at? 100. Good. Now what should I go? For x is equals to 100. X is less than or equals to 180. That looks pretty good. And then the last part we go x. What should go here?
Plus
Equals to. Yeah, which means add 20 to x each time around in the loop. And then we'll get the same code. Or it'll do the same sort of stuff. So then you can go x down 10 over x and then down 100. So these two statements are equivalent, right? These 5 lines here are the equivalent of this here. Could we write this in a different way, by the way? Instead of going for x equals 100, could I write it for int, let's see, line equals 0, semicolon, line is less than, how many lines do I want to draw? 5.
That can't be statement for line.
What's that?
That can't be each line statement.
No, it won't do anything. All it will do is just make a variable called line, start it out at 0, and each time it will add 1 to it. But what I'm doing here is rewriting this in terms of, instead of calculating x here, I'm going to calculate x inside this loop, and I'm going to use this to control the number of lines that I'm going to draw. So then you can go something like int x is equals to what? I wanted to do the same thing as the loop up above. X is equals to 100, yeah, that's it. Anything else? Plus
line
excellent. And can you see that they will do the same thing? We're just calculating x here, right? So line starts out at 0. 0 times 20 is 0. then 1 times 20 is 20, then 2 times 20 is 40. So I'm taking 100 plus this number multiplied by 20. It's the same loop, just rewritten in a different way. Everybody see that?
So if you were adding like plus or equal to 40, you would say 1 times 40.
What's that?
If you were like say it's x is plus or equal to 40, you would put line times 40.
In this here, you would do line times 40. Yeah, just think of the maths, right? Go back to the actual maths of what we're trying to do. I'm trying to generate the sequence of numbers starting at 100, finishing at 180, and going in steps of 20. It's just a different way to write the same code. So they can go for x is 10, and then over x and down 100. So each of these three ways of drawing that sequence will do the same amount of same number of lines in the same way. Which is the best way? Does anyone have any thoughts? The second one? How many people think the second one is the best way?
There's more. You have access to more variables.
The second one, to be honest with you, either the second one or the third one will work. It depends on the problem you're trying to solve and the way you want to express the solution, but they both do the same thing, so I think either the second way or the third way is probably fine. Everybody understand the third way?
Yeah.
Okay, we'll rewrite this again now using a while loop, okay? So here is our while loop to do the same thing. Have you seen a while loop before? Those of you who've read ahead in the book will probably know how this works, right? The while loop works slightly differently, and you have to express yourself slightly differently. You can have to, first of all, go int x is equals to 100. And then you write while x is less than or equals to 180. You put your code in here. Okay. So that is the equivalent of any of the previous ones that we looked at, right? That will do exactly the same thing. So how do we interpret this while statement? Okay, so the while statement looks like this. You go while, open bracket, and then you have a condition here, the same as we had a condition with the for loop, and we also have a condition with the if statement here. And inside these brackets is something that must evaluate to either true or false. So x is either less than or equal to 180, or it's not less than or equal to 180. If it's less than or equal to 180, the program will execute the code inside the curly brackets. Alright, so if this statement evaluates the truth, this happens. Just have a quick look. What would happen if I forgot to put in the x plus equals to 20 code there?
One increment interval.
You would end up with another what's called an infinite loop. In other words, the program would run, but it would never terminate. Because x is 100, next time around x is still 100, and x remains at 100. So the program will enter what's called an infinite loop. In this example here, this is how we make sure that the program doesn't have an infinite loop. Okay, because we make sure that x changes each time around. Yeah.
Does the while statement do it in one frame, or is it like, so it's exactly the same?
No, it'll do it. Oh, sorry, it does it in one frame. Sorry, my apologies. Yeah. So there's a while loop running in the background here in processing that's going while you don't press escape, call the draw method, and it will do that 60 times a second, right? So this is inside the draw method. It's a way of doing a loop inside the draw method, and that's called a while loop. Now, looking at the while loop and the for loop, you can clearly see that they're kind of interchangeable. Anything you can write using a for loop, you can also write using a while loop. So why would you use one over the other? Why isn't there just a while loop or just a for loop? Why do they bother with two different types of loops?
For loop has its own native variable. When while you have
Yeah.
to kind of rely on something else.
Here's an interesting thing, right? You're absolutely right, yeah, but look at this. You can actually write this.
You can put in x anyway.
That's a for loop. And that's a legitimate for loop as well. It just means don't do nothing at the start, do nothing each time around, and then, don't check any condition. So that's another way of writing a for loop. This is what we call an infinite loop as well, because it will just do this forever. There's no condition, there's no initializer, there's no nothing. I've just left out all the bits of the for loop. So a for loop is kind of more expressive. You can put your variable as part of the for loop. You declare your variable at the very start. And so it's a bit more explicit that you're doing something each time around. Anyway, there's a kind of a reason, and there's sometimes you want to use a while loop and sometimes you want to use a for loop. Can you think of any ideas or types of problems that one type of loop maybe expresses the solution a bit more cleanly?
Would it be like a while loop kind of it changes the game is going on? Like if you're using a variable that's throughout the entire game.
Yeah.
Like if you're using the for loop and you have it down, it's going to be the same every time. But in some case,
Sure. Yeah, I think you're getting towards the reason, all right. Yeah. I mean, while loops are kind of more flexible in a way. Yeah. Because
It's kind of like a while loop is self-explanatory. While something is happening,
Yeah.
do this.
Sure, okay.
For loop is like kind of
Yeah.
what happens before then.
Cool, so you're getting the kind of underlying kind of meaning of the two loops. But you can see that you can exchange one for another pretty much. Just rewrite the while loop as a for loop, or rewrite a for loop as a while loop. I personally think the reason why you would use a while loop, you use a while loop if you're not sure how many times something is going to execute, you would typically use a while loop. If you're exactly sure that you want to repeat this thing 10 times or increment this variable 10 times, then a for loop is better. So a while loop is more for something that you don't necessarily know how long something is going to take. Okay? So for example, reading from a file, reading from a network, you don't know how big the file is, you just want to keep on reading so long as until you get to the end. That's more the type of solution that you can solve using a while loop. Anyway, it's time for you guys to write a while loop, right? Take the first loop, or the second loop up here, this one, and rewrite that as a while loop, will you? Just for some practice, and then I'll give you a couple of other ones to write. Take that one and just write it as a while loop instead, right? Okay, let's do this. So, let's try it. Okay, so while x is less than 180, so we're trying to rewrite this, okay? So how do you take this line and then make this into a while loop? I would think something like this, you know? Int line is equals to 0, and then you go while line is less than 5. Less than. If you do less than, how many lines will it draw? Draw 5. Why would it draw 4? 0, 1, 2, 3, 4. So int x is going to be equals to 100 plus the value of line, which is generated by the loop, multiplied by 20. And then you go line x, comma 10, comma x, comma 100. And then
Line XX. Or line
line plus plus. So we add 1 to line each time around. So what's happening here? A line starts out at 0. Is line less than 5? Yes. So then we calculate x is equals to 100 plus the value of line multiplied by 20. So the initial value for x is 0. Draw our line, add 1 to line, come back in again, check to see if line is less than 5. It's still less than 5, so we'll execute this code again. And we continue on until line becomes equal to 5, at which point we break out of this loop here. Is that okay with everybody? Okay, I think people need a little bit more practice at this. Write the while loop as opposed to the for loop to just draw a series of concentric circles from the outside in. In fact, let's do it from the inside out. And just set the, can you do it from the inside out and set the fill to be no fill? Oh, yeah. I think you can just call no fill. It's nicer if you do it from the inside out.
Failed.
I think there's a method called no fill. Okay, we want to start at the center of the screen, draw a series of concentric circles that we will maybe increment by 10 or 10. Let's try 10. And keep going until we get to the x.
Do you mean like spiral out, or like maybe going outwards?
Just a circle in the center, circle, 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 until we get to the edge of the screen. Try and write that using a while loop, okay?
Any number of them wrong or
Until. Okay, so I'm going to put this up because there isn't really a lot to the while loop. If you're, hopefully everyone got something that looks similar to this. Okay, so just look up for a second, everybody. If you're still working, like just take a quick look at this. It's not. Hopefully, you just take a minute to make sure you understand every bit of it. So first of all, declare my variable w, set it equals to 100, set the stroke and background and the fill. And then we want to run this while w is less than 500. So while w is less than 500, draw the ellipse and then add 10 to w each time around. So each time around w starts at 100, I add 10 to it each time around, and then that loop terminates as soon as it becomes 500. So you get this. Okay, I think we should probably do one more while loop and then we'll kind of work on the next thing for today, which is all about arrays. So what should we do? What's that? Yeah, maybe something to do with diamond shapes. Oh, I know what we'll do. We'll do something with trigonometry. Okay? No, it's the best thing. It's the best thing. Trust me, you'll love it. Okay? Here's the trigonometry problem. Everybody look up for a second, please. Try this. Here's a cool thing. Okay, here's what we want to do. You can do this using a for loop and a while loop, right? So use whichever one you want for this, but in fact you should do both. Do it with a for loop and do it with a while loop, okay? What we want to do is generate the clock numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I want to generate these in a circular pattern around the outside of it's kind of a circular shape. So I got to print the numbers and calculate their positions as well. Huh? You can put in 12. Sure. Why not? Put in the numbers. Put in the numbers. It'll make you think. It's good. Putting in the numbers is good. And it's no more difficult to put in the numbers. Just put in the what's that? Just make the numbers of the clock using a light. You don't have to put the hands in, and it doesn't have to tell the timer or anything. All we're doing is printing the numbers at the appropriate positions around the outside of a circle. Okay? That's your next task. Of solving this, and then we'll take a little short break. Back and learn something new. Okay, will everyone look up for a second, please? So, just to double check with everyone, does everyone know how you use sine and cosine in this problem? Just say no, yes, if you want me to. Okay, I'll explain again how we use sine and cosine in this. If you already know this, then it's grand. But like I know it takes a while for you to get your head around this concept. So let's do this one from scratch, okay? I'll just explain this. So we start out obviously with this triangle thing here. This is theta, the opposite, the adjacent, and the hypotenuse. And then we had these three ratios. We said that the sine of theta is equals to the opposite over the hypotenuse, and the cosine of theta is equals to the adjacent over the hypotenuse. Alright, everybody happy with that? Yeah? You guys okay with it? You know these two ratios? Cool. Okay. So then what we're trying to do is calculate points on the outside of a circle. So I know that my circle starts at 0, and then if I was to go all the way around here and draw an angle, I would end up at 360 degrees or 2 pi radians. Just 2 pi is 6.28 go around the outside of the circle. So to calculate points on the outside of the circle, let's pick this point here and let's call this x and y. So it makes this problem slightly simpler if you imagine initially that the circle is located at 0, 0. So the center point is 0, 0. I'll just put that in there as well. Okay, that's the point 0, 0. So then if I draw a line straight up here, and I imagine that I have some angle here, and if I draw a line across here, you see that that is actually a right angle triangle. So same as the right angle triangle over here, it's just rotated. So the same ratios apply, right? This is the opposite of that. That's the adjacent, and that's the hypotenuse. So the same ratios, the sine of theta is the opposite over the hypotenuse, cosine of theta is the adjacent over the hypotenuse. Now looking at this diagram here, here's the key to understanding the unit circle. The key to understanding the unit circle and how this thing works is to realize that the opposite side of this triangle is what? The opposite side of that triangle is
The x-coordinate distance.
is the x-coordinate distance. Look, again, the distance from there to there, that's the x-coordinate distance, right? That's the x value of this pair of numbers, this tuple. Right, these two numbers here, x and y, you can see that the opposite side of this triangle is the x number that we're looking for. Can you see that? And you can see that the adjacent is the y number because it's the distance from the center to here. That's the y number. So if we rewrite this a little bit, we can say that the sine of theta, also you can see that the hypotenuse is what? What's the hypotenuse? It's the radius of the circle. It's the radius of the circle, because the distance from 0 to the outside of the circle, that's the radius of the circle. So we can say that the sine of the angle theta is equals to x over the radius. and the cosine of theta is equals to the y over the radius. Alright? Alright with everybody? So, then just to rewrite that, we multiply both sides by r, and you end up with the sine of theta times r is equals to the x value, and the cosine of theta times r is equals to the y value. Okay? Next step, because this is processing, I know that if this is 0, 0, then this y number is going to be positive or negative.
Did you mean to wipe out that?
What's that?
You have sine theta or equals y.
Yeah, sorry, that should be x, thank you. Should be x, yeah. So, yeah, the y is negative. The y is negative or positive in this example. It's negative. Why? Because if this is 0, 0, 0 is in the top left-hand corner of the screen, isn't it? So if I want to go above the top left-hand corner of the screen, it's going to be a negative y, isn't it? To go down the screen is a positive y. So in this example, it's sine of theta is equals to, or the sine of theta times r is equals to the x, and minus the cosine theta, r is equals to the y. Y again, imagine 0, 0. 0, 0 is the top left-hand corner of the screen. But when I calculate this point up here, I know that my x is going to be positive, my y is going to be negative. So that's the algorithm we use for calculating points on the outside of a circle using trigonometry. That's our principle. So if I want to calculate 12 points around the outside of the circle, I just take 2 pi divided by 12, and then I write some for loop to calculate the theta value, and then I calculate the x value and the y value using these little equations here. I just write this in processing code, and this will give me points on the outside of the circle. The last thing about the unit circle is currently this unit circle is centered at 0, 0. If I want to move this entire circle to the center of the screen, all you do is add 250 to the x and 250 to the y, and that has the effect of just translating everything. So you can actually take something like cent x plus this and cent y minus that. So the center of the screen plus the sine of that, and the center of y minus the cosine of that multiplied by r gives you the same circle but centered in the center of the screen.
Can you just distinguish why it's plus and minus for sin and then minus for cos? That always
Yeah, sure.
goes over my head.
So if we imagine the processing window is up here. Okay, the x and y coordinates, the origin is in the top left-hand corner of the screen there. So if I'm trying to calculate a point up here, what's the x for that? The x is positive, right? Because I'm going from left to right for the x. But the y is actually negative because it's off the top of the screen. You see? If my y was going downwards, if my center point was here, then it will be positive y. But because my origin is in the top left hand of the corner, I know that minus y means go upwards, positive y means go downwards. And that's why it's negative y and positive x. Positive x brings me from left to right, and positive y brings me from top to bottom. So if I want to go from bottom to top, it's negative y. So that's why you get negative y. So that's the maths behind how this works. And then let's write some code. So there's 4 different ways we can solve this. Let's do it using 2 for loops first of all. For loop number 1 is to basically say there's 12 numbers I need to calculate, and let's calculate those 12 numbers. So let's go. Theta inc is going to be equals to 2 underscore pi divided by 12.0f. It is very important that in this example you make it a float rather than an int, because if it's a float, you can have numbers after the decimal point. If it's an int, we're stuck with 1, 2, 3, 4, 5, 6, right? So we don't have any of the decimal numbers. Yeah.
Where does theta inc come from?
I just declared it there.
You just made it up.
Just made it up, yeah. Typically in these ones I'll call it theta inc because it's what I want to add or multiply theta by, like theta increment is the short form,
Where's 2 pi?
2 pi is built into processing. It's hard code. It's a constant that you don't need. It's just part of the processing framework. So whenever you need pi, you just use pi, and 2 pi is 2 underscore pi. So they're kind of hard coded in processing, if you like, right? So now I can go. How many do I need to actually draw? 12, right? For so many ways to write this. For I equals 0, semicolon I is less than 12, semicolon I plus plus. Now, I'm kind of thinking maybe a better way to write this is for I equals 1, I is less than or equals to 12. The reason why is because I don't want to do 0 right at the top. I want to do 12. I want 12 to be the last one that I draw, Just looking around, it seems people are figuring this out for themselves, So then, x is going to be equals to 250, center of the screen, plus the sine of, let's calculate a value theta. Theta now is going to be equals to I multiplied by, okay, so if I is 1, I'm going to get the coordinate where I need to place the number 1, and if I is 2, I'll get the coordinate where I need to place the number 2, and so on. So then we take the sine of theta, multiplied by the radius. Let's pick a value for the radius, let's make a variable for it. Let's say radius is equals to 200. And float y is going to be equals to 250. Of course, all of these really should be 0.0f, you know, to make sure that this calculation happens in floats rather than in integers. Okay, so now I've calculated my x and y, and then we can go text I, comma, and then the coordinates x and y. So again, this is just one of lots of ways. I'm looking around at people in the class, and lots of people came up with similar but slightly different solutions to this. Let's see if this actually works, right? What I might do here is, I would just try and run it and see what happens. Okay, duplicate local variable x, because I probably already have one called x. So why don't I comment out this previous code up here, star that thing. That, and let's see, does it work? Yay! See that?
Got it.
Okay, so that's the first. Does everyone understand that? Look at the code again, right? Look very carefully at it and make sure that you understand every line of it before we go on, right? You know, from first principles, from the trigonometry down to the code, can you see how every little bit of that like contributes to the solution? Okay.
That theta I times theta inc, I wouldn't have thought of that.
Why? What way did you do it? Oh, okay, okay. So I think this is a nice way of solving it. It's just a minimal amount of variables and stuff, you know. To me that just seems like everything's calculated in the right sequence. You know?
We had mostly the same stuff.
Yeah, you might have got something similar. Okay.
There was something that was really screwing me up when I was about half an hour trying to figure it out, is that, do you know the flow I, or the integer I? You know, I was using that in the what I was calling
Okay.
and I was using it with an angle.
Right.
And it was kind of rounding up, so it was 1, 2,
right.
3, 4, 5,
Use the
6, 7.
integer. Yeah. So that's a really common kind of thing as well. Like when things are ints and floats and stuff, when they're not the right data type, sometimes the calculation will get done incorrectly because you're using a float where you should use an int. Not to worry. Hopefully this kind of explains this a little bit better. Let's do it another way. Let's do it using a while loop. While I is less than or equals to 12, because I want to do 12, you know.
Will that not give you 13?
Yeah, we can start with one.
Hopefully, yeah.
We had, it gave us 6 with the lines in it.
What's that?
It gave us 6 with the
that's one.
I don't know. Tell you what, let's try it and see. Let's try it and see, okay? And then I think we should probably have the same code here. There's another really interesting thing happened here. Look at this, right? You might notice that I have a while loop here. And I have all these variables here. And I have a for loop just above it with the same variables. But you know what? Processing will allow me to do this. Why will it allow me to do this? Because these variables are declared inside these two curly brackets here. So these variables get created and destroyed. As soon as this curly bracket finishes, these variables don't exist anymore. You can do that. You can reuse the same variable names in different loops, so long as they're surrounded by different open and closed curly brackets, right? Because that's what's called scope, right? So this is the same code written as a while loop, okay? So if I comment out the first one, hopefully you'll see that this will do the same stuff. And of course you can use the Theta Inc. Version as well. I'll just show you how that works. Okay, something's, what's happened here?
Background.
No,
Infinite loop.
infinite loop. Infinite loop. What have I forgotten to do in my while loop? You have to increment I, otherwise it will just stay there forever with I is equals to 1. So I plus plus is necessary there, yeah? And there we go. That's the same code, same program, just with a while loop. And let's do just one more example using the kind of theta, using theta in our control kind of variable. Probably need to declare this. Theta equals theta inc. Theta is less than or equals to 2 underscore pi, semicolon.
You have to clear float before you use text. So like say if I said text number x and y and then put the float below it, will that call it like in the same while will it call it last?
No, the variable that you're using in text needs to be declared before you use it, if that makes sense.
Yeah.
So now, okay, we have a little problem here. We need to calculate I. So we need to probably declare this variable I. Int I equals 1. And then we have this same kind of stuff up here. We're calculating x and y. Okay, so this is the same code, just written a slightly, I guess maybe this is a little bit more long-winded, because now I need two control variables. I have I, which I need to increment each time around, and I also have my theta variable that gets incremented or added to each time around as well. So it's the same, just written as like for going through the angles rather than going through the numbers that we want around. Maybe we should take a short break now, okay? Let's take like a 10-minute break and we'll come back and do one small thing then before we finish. Right? I'll introduce the next things. We don't have enough time to do too much detail today. So, see? I think a while loop is the right way to solve this one. Everybody take a quick look up. So I give y an initial value of height divided by 2, the center of the screen. That's halfway down the screen. And then I make this other value called y-inc or y increment, what I'm going to add to y, and I set that initially to be 2. And then you go, while y is less than the height, then I draw my line from 0, and there is extreme left, down y, over to the extreme right of the screen, and then y. Y plus equals to the y inc value, and then I add something to y inc each time around as well. So every time, first time around I add 3, next time around I add 6, next time around I add 9, and so on. Okay, so here's the last problem. I'm not even going to attempt to start this one now, because this might take you a little while to figure out. And if you want a little bit of a practice problem, this is a really good one to do. So if you've ever read the Da Vinci Code, you might have come across this sequence of numbers called the Fibonacci sequence of numbers. 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Each number is the sum of the previous two numbers. Look up everybody. Sum of the previous two numbers. So 0 and 1, add them together, you get 1. 1 and 1, you add them together and get 2. 1 and 2, add them together, you get 3. 3 and 2, you get 5. 3 and 5, you get 8. So every subsequent number, every number is the sum of the previous two numbers. So this is a classic kind of computer science first year problem that everybody has to do. It's called the Fibonacci sequence. Very interesting thing about the Fibonacci sequence, it looks like a rather trivial and not very important sequence of numbers, but it's another one of those things like the spiral that's absolutely fundamental to how lots of things in nature work. If you ever go to France and you happen to see fields and fields of sunflowers, tournesol they're called in French, and you take the time to go and count the number of seeds on the head of the sunflower, you'll find that it's always a Fibonacci number. It's always a number in this sequence of numbers. And there's lots of things. There's a type of spiral called the Fibonacci spiral. And if you analyze the way a lot of shells and sea creatures, the shape of the cells, they're all Fibonacci spirals. So in other words, the radius increases by a Fibonacci sequence I think it's every quarter of the circle or half the circle.
90 degrees.
So the Fibonacci sequence is, what's that?
Every 90 degrees.
Is it every 90 degrees? Yeah. So the Fibonacci sequence is a very, very important sequence in nature as well. And you can generate the Fibonacci sequence using a while loop. So that's your homework, okay? And we'll leave it at that for today, and good luck in the exam on Wednesday, okay?